Ajá. Okay, so it's time for our next talk. It's a pleasure to present Arnoldo Díaz Ramírez from Instituto Tecnológico de Mexicali. His talk is precision irrigation based on the paradigm of Internet of Things. Arnoldo.
Thank you very much. Thank you for the invitation. Learning to know what other people are doing in our state is very important for us. And we want to present what we are doing at Tecnológico de Mexicali because I think the idea of seeking for collaboration in research projects is a very good thing. Well, this is my name. I'm part of this research group called K. It stands for Industrial Informatics Academic Group. And what we do in that research group, we do real-time systems, and we are also working right now on embedded systems, also cyber-physical systems, which are based on the above technologies, and Internet of Things. And fortunately, these technologies are the base of Industry 4.0. So we are now interested in mastering technologies in order to do things related to this area. So the first step for us is to master these basic technologies. We are right now doing more implemented-oriented projects. We have one master program on computer sciences, which is part of the PMPC of CONACYT. And the idea is to present one project that is important for us because we are learning how to deal with these technologies in a implementation basis in order to do more theoretical projects on base of that. All right, we are seeking always for collaboration. Worked in the past implementing some of the algorithms that, for example, Victor has and his students has done. And we are always open for new ways to collaborate. Well, we were invited to a project related to agro-industry, and we found that the scarcity of water is a very important problem. Maybe here in this area, or for example, Ensenada, you suffer more from the scarcity of water. Right now in Mexicali, we have plenty of water, but maybe in the near future, we will be suffering of the scarcity of this natural resource. Well, from the total existing water worldwide, only 3% is fresh water available for us because are in the ice caps, for example, in the North Pole. And only 1% is for humans. And for this 1%, 70% is used by agriculture. So for human consumption, we have very limited resource. And we need to use this very efficiently because if we don't do that, maybe we'd end up with not enough food project, and we found that this is a very important problem, and we found that what we needed to do is some sort of project regarding precision irrigation. What is precision irrigation? Well, the idea is to decide how and when to apply water in the right amount in order to use efficient use of this Internet of Things to implement this kind of ideas. This project was funded by the Ministry of Economy, so we did a lot of research, and we found that there is a point called permanent weeding point that is very important when the plant has not enough water, whatever you apply to the plant. So we found out that if we can measure the amount of water there is in this area, we can use the right amount of water, and also we are able to avoid the death of the plant. So the idea is not to overwater the plant or to dry the soil. So we decided, found that there was an opportunity to make a contribution. Even though this model is plenty used, we wanted to introduce new elements to the model. And we needed to decide, for example, which is the best sensor to be used and how to get data from this sensor and what to do with this data in a data processing unit, how to send it to a server and then send it to the cloud to be processed and to send notifications in case that everything goes wrong. And we are pending to close the loop, trying to, for example, apply machine learning to the most used sensor worldwide. This sensor measures how much water is in the soil. What it gives you is the measure is in centibars or kilopascals. And every plant has a threshold of how much water does it needs to be in the soil in a permanent way in order to be healthy. So we decided not to build the sensor since this meter, which you need to read the measures manually. And this is very impractical because if you have a large area with agriculture products, you need to move all around the air device to send wirelessly the information through a sink to a server. But it's very expensive and it is also a very close technology. You have to use always the technology. You cannot change everything. So it is not practical. So we decided to create our own data acquisition unit. Professor Veronica, which is here, was in charge in this area. Registering this as a utility model at the INPI, the Intellectual Property Agency of Mexico. And thanks to this, we can take the information and process it any way we want and send it using any protocol we want. So this is a great advance for us. And they work very hard. They compare, for example, the measures of the original device with the measures that this acquisition unit gives and are the same. So they did a very good job. So the next step was unit. We did a lot of research, and for our surprise, we found that almost everyone used things like Arduino or Raspberry Pi or a microcontroller with using the original language of the microcontroller. But we found that this was very limiting. We wanted a data acquisition unit that give us freedom to do whatever we want, to connect whatever device we want and to send it using every protocol we wanted. So we found this cheap and small microcontroller, which is here. It costs only $6. And we found that even though it's small and it is very powerful, at least to do IoT, Internet of Things application. So we decided to use it, and we wanted to install into the microcontroller an operating systems. Why? Because with that idea, we were able to implement whatever logic we need to implement. So we are not limited to the language of the microcontroller. So we found that NATX is a very, very used and very powerful operating system. In fact, it is a real-time operating system for the project like Industry 4.0 projects. We found that if we learn how to use and how to master this operating system, we can use what we learn in more interesting projects. And among the things that we found attractive in this operating system is that it is PASIX compatible. This is important because we can change the operating system, or we can develop the application, for example, in Linux or iOS, and we can move the application into the device and will work with any change. Also, we have the opportunity to use p-threads. Using p-threads, I can control a lot of the computing, decide what to do or which is important about what we are reading, and to send it at the same time. So these features were very interesting for us, so that's why we decided to use NetX. As I told you before, we didn't find in the state-of-the-art research that we do that anyone are using something like this, which is surprising because this is information that is available right now. But we found very restrictive projects. So we are using a platform that gives us a lot of flexibility. And to send the information to the server, we are using Zigbee to enter to this technology, and she gives light, and she already finished this part of the project. And the next thing to do is, well, since we are thinking that this could be used in very large zones with a lot of sensors and a lot of information, a natural way to store and process that information was using cloud services. And we found that there are a lot of cloud services providers that have solutions for IoT. For example, the web of Amazon has a special section of IoT applications. This is very interesting because you related to that device, and you can apply any logic or software you need to process among the data. We found this cloud provider. It is former Spanish provider. Now it was sold, and it's very interesting because it is a platform for IoT. And we decided to use also the MQTT protocol. If you are not familiar with this protocol, it is a kind of publisher-subscriber protocol. And it's very interesting because it is very easy to use a cloud service and to use our own server. We can implement a MQTT server. For example, Mosquito is an example of an open source provider of these services. And you send the notification to the server, and all the devices that are subscribed to that service will receive the notification. So it's very, very easy to use. So instead of, for example, web services, we decided to use this protocol, and it's working very to mobile devices through SMS messages and also through email. So when we detect that some zone of the agriculture area is, for example, dry, we send a notification. Hey, you need to add more water. Or if it has too much water for too much time, we say, hey, you don't need to change the Zigbee, and we want to try LoRa, which is a protocol for wireless networks that is oriented to IoT also. Which are the difference? With this protocol, I can have a lot of sensors or a lot of devices, Zigbee devices, and these devices are used. I can use all the intermediate nodes to send the information. With LoRa, I have a lot of range, so I cannot I'm able not to use those intermediate repeaters, and we have a long range with very small energy consumption. Days, we will recommend to increase the application of water, or for example, like in these days there is cold, maybe we can adjust the application or the irrigation program and not to apply too much water because it is not needed. And using what we learned in this project, what we are very interested in, we are autonomous control of robots, UAV, and cars. We are, with these students that are here, thinking about using the information to that project. Hope that that's it. Thank you very much for your attention.
In an open field, or why you don't try to use it in a greenhouse? Because you know a greenhouse it's a very small place where you can put all your sensors and have better information. In an open field, I mean, I know that maybe it's going to be useful, more useful, but
the proposal is can be used in both scenarios. So you can use it in greenhouses. You will need fewer sensors, for example, and maybe the energy of the microcontroller, for example, will be more efficient to use. But it can also be used in open field. The use of Zigbee allows us to use it in open fields and use the intermediate nodes as repeaters, so we don't have the problem of the size of the area.
Okay, in the next step, when you are going to implement the machine learning, are you going to use the node and this microcontroller? It works with machine learning, or are you?
No, the machine learning techniques will be applied on the cloud. The microcontroller is also only to get the information from the sensors.
Okay.
We plan to add more sensors in order to the machine learning model can have a lot of information to make decisions. So connected to everything you need in a very cheap fashion.
Another question? Yes.
Besides the signals from the sensors that only measure the humidity and the water in the plant?
Right now, it's the only thing we measure. We are planning to add, for example, temperature measures.
Okay, I was going to ask, which other variables are you going to take into account for implementing the machine learning methods?
Yeah, right now we are thinking about using temperature, but we need to do a lot of research, or some research to know which one will be. Agriculture right now only use that sensor. So we wanted to replace the current system with a more flexible system. Remember that they have to go manually to read every sensor, the information of every sensor, which is very, even it is prone error. So the idea was to replace what they have with a more efficient system. But right now we're thinking how to improve it using those techniques that you are suggesting.
Thanks. And only one quick question. These sensors, they work in the field like one per plant?
No, they use kind of a cluster of plants. What the agriculture do, they put the sensor in the middle of the.
Okay.
Another question? I have a question. Machine learning, what is the goal of using machine learning in your plan?
Since the idea is to use rational use of the water, what we want to do is to give some advice about how to define the irrigation plan. That's the idea. Because what they do is they say, well, we want to irrigate every 3 days. It doesn't matter if it is needed or not. And maybe we can anticipate events and say, oh, you will need to short the period because we estimate that it will be a very hard days or any other variable. We don't know yet.
Okay, so it's in the decision-making process, not in the IoT system.
Yeah, that's correct. Yeah, the decision process. The idea is to advise or to tell the agriculture people.
Thank the speaker again.
Thank you.